So when we look at 1.6, the reason it is at the end of the chapter, it's a combination of your skills with absolute values and your skills with inequalities all mashed together. So it's kind of a good way to be a combination of all the things we've learned. So it's pretty much one of the harder of all of our sections. We need to know some of the language and what we should do when we encounter different types. So that's what I want to talk about. First off, let's talk about what it means to be a compound inequality. So there's two types of compound inequalities. One is an and one is an or. What is the difference? The and will be an intersection. Many times we think of it as a between. So we're between two values. So we are looking at where this is true and simultaneously this is true. Or is considered a union. It is the combination of many different things. So if it's this or this, I can be over here or I can be over there. Both would be considered correct. So there's different things we have to do, and they're going to look differently. So for the and ones, usually we have some x value between two numbers. They're going to have to be in least to greatest order. If they don't appear when you solve them to be in least to greatest order, are they greater than symbols? No, they should be less than symbols, so you might have to turn it. If they're not in least greatest order, is there no solution to that particular problem? For the union, it would be something like x is greater than 5 or x is less than 2. Okay, so it's going to be two distinct things. It will be two distinct actual pieces, okay? On the number line, let's talk about what they look like. So if we really just look at the numbers 2 and 5. The top one, we are all values from 2 to 5, not including 2 and 5 because they have to be open since there's no equal to. We learned that before. But it can be any value between 2 and 5. So 2.6 works, 3.1 works, 4 works, 4.99 works, everything between 2 and 5. Let's take a look at the union one, x is greater than 5 or x is less than 2. You just plop those on the paper. That is your answer. So this would be everything to the left of 2, and this will be everything to the right of 5. I almost think it's a silly way to think of it, but if this were a boat, these are the oars off the boat. The oars have two pieces very commonly. It's a silly way to remember it, but I like the silly. It works, okay? Now, what's interesting, the reason that the 2 and 5 is an intersection, the top one is an intersection, it's technically looking where it is greater than 2, but less than 5, and so it does become between 2 and 5. Now, we don't have to, with the luxury of this notation, we don't have to look at the intersection. It will do the intersection just on its own, but that's why it happens the way that it does. So in example 1, we're going to do a compound inequality that is a between, an and then in example 2, we'll do an or. Okay. Any questions so far about our notation and how that works? Okay, so let's do one of each. Let's start with example 1. In example 1, what you're trying to shoot for is you want to get your variable alone in the middle. You want to get your variable alone in the middle. Okay? So we need to isolate the y. I think of this as almost like a 3D equation. Instead of just having a left and right side, whatever we do to both, we do to both sides, here we have three pieces. We have three dimensions that we have to do everything, whatever we do to the left, we do to the middle, and we also do to the right. So if I just told you you had this inequality, that if we just focused on this piece and forgot that that 8 was there, if we had 3y minus 7 is less than or equal to 23, what's the first step we would take to get that 3y by itself? Tell me, what would we do? We would add that 7, right? Okay, so the first thing we do here, when you add the 7, you have to add it in all three dimensions, I think, left, middle, and right. Whatever you do to one piece of this 3D equation, you do to all pieces. When we do, we get that 15 is less than 3y, which is less than or equal to 30. Okay? Now, again, just focus. If we had this inequality on the right side, 3y is less than or equal to 30, what would be our next step? We would divide off that 3. So let's take that step. Let's divide. Now we have to divide all three dimensions, left, middle, and right, by 3. I'm going to write my answer to the right here. My final answer would be that 5 is less than y, which is less than or equal to 30. Now, I don't really read it like that often. Most of the time, I'm going to say that y is between 5 and 30. It is allowed to equal 30, though. Okay? Now, 3 divided by 30. Like, I thought last time it fit. 3 divided by 30 is 10. How about y is between 5 and 10? Okay. So now we're going to go to the graph paper. On the 5 dot, we have to have an open circle because, if you'll notice, we do not have an equal to bar. On the 10 spot, we do have an equal to bar, so that at the 10 is going to get a closed-in dot, and then we're going to shade everything in between. Now, if you stick 7 into the original inequality, you should get a correct statement. Like it say, because we shaded in 7, if we put step 7 in, we get x is less than 14, which is less than or equal to 23. Yeah, that's a true statement. So you can pick one of the numbers you've shaded, plug it into the original. If it comes out as a true statement, you're probably right. And that's a great way to check your work. Any questions about our between ones, our intersection ones in example 1? You good? Okay. Now, example 2, you'll notice it has two distinct inequalities with the word or between them. You're going to solve each one independently, just going to solve it. So like our first one, I would subtract 6 from both sides. We get that k is less than negative 10. And then write the word or again. If we look at our second one, to solve that, we would divide both sides by 3. And we get that k is greater than or equal to 4. Now, with the or ones, whatever we color in on the page is our answer. It's just our answer. So k is less than negative 10. We'll have an open circle at negative 10. We're going to shade to the left. K is greater than or equal to 4. We're going to have a closed-in dot at 4. We're going to shade to the right. And just like the two oars on the side of a boat, we have those two pieces going to each side. That's pretty common. There are times where you color in the entire number line. That just means that everything works. And sometimes you can rewrite your answer just using those words. All real numbers work, or all reals is fine. Okay. Everybody good with solving the ands or the ors? Okay. And we talked about these a little bit, but the reason I wanted to revisit these is because what do we do with an absolute value inequality? Okay. There are two types. I'm going to kind of generalize so then you get the idea. If we have the absolute value of x is less than or equal a number, we'll call that number a just for the heck of it. Okay. We have one thing we have to do. If we have an absolute value is greater than or equal to some number a, we have something else we have to do. Now, the equal to just goes along for the ride. It doesn't hurt anything. Now, when we were doing lesson 1.1, 4, when we were doing lesson 1.4, we had the absolute values and we set up the positive case and negative case. We do have 2 cases. Here's what you do, okay? You just have to learn this trick so that when it's time to implement it on a quiz or a test, you understand the trick. But here's it is. If it's a less than, you drop away the absolute value. You know how we have 2 cases? We are going to stick the negative case on the other side. So this becomes a between. It becomes actually an intersection. So it becomes a between. A little note about an absolute value. If you have an absolute value of x is less than a negative, is a positive less than a negative? No, we know that. We know that positives are bigger. So this would be a no solution. And so if you see that, and when you go to try to look for an intersection, or if you go to set up the inequality, you'll get that like a number is between, is greater than 2 but less than 1. How can that be? That's not true. There's no number that's greater than 2 but less than 1. And so it'll mess up the order. And so if you see the absolute value related to a negative, if it's less than a negative, that's never going to work. Okay. Now let's talk about what do we do if it's an absolute greater than. The absolute greater than becomes an or. It becomes a union of 2 sets. And so the positive case, you just rewrite it, just like we did for our equations. Then you write the word or. Now what the negative case does is it takes all of this stuff and makes it the negative. When we multiply an inequality by a negative, what do we have to remember to do? Flip it. So what the negative case does is it flips the sign and the number. Okay, so don't forget this negative case flips the sign and the number. So your positive case, you just rewrite it without the absolute values. Your negative case, you're going to flip the sign and the symbol. You flip both. Okay, here's the thing to remember here, a little note make to yourself. If you have an absolute value is greater than a negative, it's saying a positive is greater than a negative. Isn't that always true? And so that would be all real numbers. You could even make the R with the special little double back. It looks like a TR, but it's a R with a double back. Okay? So you just have to memorize these rules. Here's where Algebra 2 starts to be more difficult than geometry and Algebra 1. We've got those more rules that we're coming on, more things we have to recognize. So you have to know, if I see an absolute value greater than, I set up my 2 cases with an or between. If I see my absolute value less than, I can make it between the positive and the negative case. Okay? So that's where you want to learn. Okay, so let's go ahead and let's look at example 3. Now, example 3 I just made very simple so that we could just get in the habit of what to do when we get to that point. And then example 4, it's a little more complicated. Okay, so let's look at example 3a. The absolute value is greater than 5. If we have the absolute value is greater than 5, greater than, remember, is the or. So we're going to set up the 2 cases. Our first case, we just rewrite it without the absolute values. Write the word or. The second case, we leave the x alone without the absolute values. We flip both pieces of the next piece. So it becomes a less than, because that flips, and it becomes a negative, because that flips. And then if there was math to do, we would do math. But this one is a pretty simple version. And so at 5, we would have open, shade to the right. At negative 5, we would have open, and we would less than would shade to the left. So an absolute value greater than becomes the distance that is 5 away from 0 and further than 5 away from 0, greater than 5 away from 0. And so that's why that distance goes out from 0 on both sides. Okay, so that's what you do if it's an absolute value greater than. I think absolute value less than is almost easier because you just rewrite it. It's going to become a between, and you just stick on the same exact symbol with a negative on the other side. Okay, so for an absolute value less than, we stick the negative version on the other side because it's an intersection between -2 and +2. So then we would go to the graph paper at -2, closed in dot, +2, closed in dot, shade and everything in between. Now those are the simple cases because I just wanted to show you how those simple cases looked on the page. And now we're ready to look at example 4, okay? Now example 4, we have a less than, we have a greater than or equal to. So let's start with 4. Well, I don't know why it says B, but let's make that A. Let's look at 4A. Okay. So these ones, we have some more work to do, okay? So let's take a look. If you see absolute value less than, remember, that is going to be a between. So we take off the absolute values and just write exactly what we see. Take off the absolute values, write exactly what we see. Use the exact same symbol on the other side, make it a negative. So that's what you're going to do when it's more complicated. Okay, so let's look at what we did again. Drop the absolute value off. Rewrite exactly what you see. Stick on the exact symbol on the left side with the negative. Okay, and now it's one of those 3D equations like we saw earlier. So we are going to add 5 to all the pieces. We get -8 is less than 6y, which is less than 18. What do we have to divide off to solve? What do we got to divide by? We got to divide off that 6. If it divides nicely by 6, do it. If it doesn't, I like that reduced fraction, but again, you got to think of where's the decimal value. You get -4/3 is less than y, which is less than 3. Now, 4/3 is 1.3. So when we go to graph it, you can just put 4 divided by 3 in your calculator. It will show up as 1.3. And so we should be between those values. So over on the graph, just guesstimate when you have a decimal. -1.3 would be about there. That's about -4/3. That is an open circle, sorry. And 3 has an open circle and shade in between. Let me make my, okay, so -1/3, 1 1/3, +3, shade between. Those are open circles. Okay? Okay, so that is an absolute value less than. Everybody good with how I did that? Okay. Now let's go to an absolute value greater than. Greater than is an or. We're going to set up the positive case and negative case. So we need a positive and a negative case. We had a positive and negative case for the other one, but it was stuck to it. And that's why it kind of becomes pretty nice. Okay, so just rewrite it, drop away the absolute values, change nothing. Rewrite it, drop away the absolute values, change nothing, write the word or. Rewrite the left side, drop away the absolute values, 5z plus 2. Change everything for the negative case. Changed everything on the right side, including the sign for the negative case. So to become less than or equal to -17. Because think about negatives and inequalities flip things, if that helps you. Okay? So that's what our plus and our positive case and negative case looks like. Now they just become individual inequalities to solve. Subtract 2. 5z is greater than or equal to 15. Divide by 5, we get that z is greater than or equal to 3. So that's our left one. Now let's go ahead and do our right one. If we subtract 2 from both sides, we get that 5z is less than or equal to negative 19. And then we're going to divide both sides by 5. Now, 5 dividing by 5 and by 2 gives me a super nice decimal. And so we get that z is less than or equal to negative 3.8. So think about the or. Absolute value greater than should be the pieces going outward. So at positive 3, put on a closed-end dot, shade to the right. Negative 3.8, get as close as you can, guesstimate. Shade to the left. Are we good? Any questions about those? Okay, now, the homework's on the next page. There's only 10 problems. I expect to see you solve the inequality, and then I expect you to see, show the graph on your number line. You don't have to, be super specific as far as when you graph the number line. On the back board are the answers to the inequalities. I didn't show the graphs, but you can do that, please. And then tomorrow in class, it's a very shortened class, half hour. You'll have time to finish up your 1.5 and 1.6 homework.